الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmina.
Okay, so hello everyone. Welcome to this session of the 45th week of the MENA Digital Days. Thank you, GDGMina, for having me. My name is Taha Bouhsine. I'm a data scientist and the current lead of the GDSC Ibn Zahir University. Today, we're gonna see a gentle introduction about exploratory data analysis, and where we'll discover the different popular techniques used to discover, understand, and talk with data. And so, before starting the session, let's just have a thought play. Let's just say that you are sitting with your friends, with 7 of your friends. Let's just say 5 of them, and you are the 6th one. You are sitting together in a room, bored, and as everyone was holding his phone and just playing with his phone, and you wanted to break that mood. So in order to break the mood, you ask them to play a game. Then one of your friends liked the idea and suggested to play a game he read about on the internet, which was the Russian roulette, which is a game where you put one bullet in the chambers of the revolver and you roll it, then shoot. And for the sake of the story, you told him, let's just say that you told him, hold up, that's not safe. Is it actually safe to play? And then he told you that he read about it on the internet that say that it's 100% safe. And then he showed you the article, which says that they have interviewed 1,000 persons that previously played the Russian roulette before, and 100% of them have survived the game. Thus, the conclusion was that the Russian roulette is safe to play. So, what is your decision? Would you play the game with him or not? Do you think it's actually safe to play this Russian roulette? And where did you think that this said? In case you think that this study had made mistakes, where do you think those mistakes are? And where did your friend, who may his soul rest in peace because he played the game, who believed that this story was true, made mistakes? Okay, so let's just leave this questions open and to keep your brain active during this session as we go along this talk, inshallah. Okay. So, what is EDA? EDA, or exploratory data analysis, is a process of talking to your data and trying to understand it, discover the stories in it, and the different lies and biases lying within it. It is a never-ending process, structured without any defined rules, where you iterate and ask as many questions as possible in order to extract as many insights as possible, which will help you and guide you through all the subsequent modeling of your modeling and assist you out in creating an effective data-driven solution. And you gotta live with your data. You gotta understand your data, and you gotta be your data if you want somehow to build a data-driven solution. And in order to do that, you gotta ask some questions. And during this process, we try to ask as many questions as possible, as we said. And mostly, we try to answer the following questions. How was this data collected? Where did it come from? And is the samples I'm working on are representative or not? Is my data clean? Is there any bias embedded in my data? And how is my data distributed? Did I ask my data enough questions? Is there a correlation, or it is just acquisition instead of correlation? And the results, which help us, and the results of this EDA, this process, help us to detect many problems that may lay within our data, like detecting outliers. It helps us in reducing the dimensionality of our data. It helps us in detecting the patterns in time series and discovering the relations between the features of our data, and also choosing the right machine learning model to use and improving its results. and if we didn't sort the data enough and ask it a lot of questions before feeding it to our model, surely enough, we will build just another machine learning model that will surely fail. And as you might find it fitting the wrong things of your data, which might introduce a high variance to your model and leads our model to losing the ability to generalize on new data. Or it might just fit on hidden biases in your data if your data was systematically dirty. And finally, you will end up building a model that will create more problems instead of solving old ones. And back in 2019, a study was published on Nature where it reveals the damage caused by a machine learning model used by United States hospital. It was used to decide whether a patient was eligible to benefit from a support program for people with extreme medical needs. And what they have discovered was that the model was making a lot of racist decisions when it comes to deciding the eligibility of Black people, as they have cited in the article. When two persons, one is Black and the other was white, whom have the same medical and social condition, the model seemed to always prefer the white person over the Black person, even though they are quite similar. They have quite similar condition. And when they started digging deep into it, they have discovered that the data collected from the real world was systematically dirty. And as the score which decides the eligibility of a black person was always low in comparison with a white person, which caused the model to learn from a racial bias pre-existing in this world and got affected by it and started to make racist decisions. Hence, it is a crucial task for every machine learning project and every machine learning engineer and every data scientist to first explore the data before feeding it to the model. And after the evaluation of your model, you should try to explore the data more thoroughly to look for ways and means to improve your results. And in case we did skip this exploration phase, as most of people do, we will face many challenges and unnecessary problems that would have been easily avoidable if we did explore the data beforehand. And as a good example of that is a company that was tasked by a hospital to create a cancer classification system. Using data provided by the same hospital, of course, the deep learning engineers trusted that data and fed it to those images directly to the model without first exploring and visualizing them. Skipping the exploration phase, and in the evaluation phase, the model was given amazing results, exceeding the state-of-the-art results, and something that is great. They were quite impressed with these results, and didn't suspect a thing. They delivered the product to the hospital and were thinking about creating an article about it. And a few days later, the hospital reported that there was something wrong with the model, as its accuracy was below 15%, which you can get just by a simple 50-50 guess, a simple function that have a random function. You can get a better results than that. So they started looking into it. Everything seemed to be fine. There was nothing wrong with the deployment of the model in application that they were using. There was nothing wrong with when they evaluate the model on the data set that they have previously. Everything was just working just fine, and they didn't know where is the source of the problem. So they thought, then decided to just say, let's just visualize the data and look at it. And soon enough, what they have discovered was that most of the medical images of patients having cancer, there was a circle on the parts that the doctors that diagnosed that person suspected that there was cancer in them. So the model that this company has created, it's not a model, it's not a classification of cancer, whether a patient have cancer or not, but it's a classification whether a patient have cancer, whether a medical image have a circle in it or not. So everything that the whole project was going to waste because just because they didn't visualize and they didn't explore on the data beforehand. Okay, do you have any questions about this? About what we have seen so far? feel free to ask. No questions. Do you have any questions about what we just saw? Or should I just... Can you speak Arabic, please? Oh, sorry. Oh, sorry, this is an English session. I can get in a hands-on practice on thing. We can see some examples later with data sets to analyze it, but it's not just right now. We will see it later. The EDA is parts we can, as I said earlier, we can you can during the second phase of exploration data, of the cleaning of data, you use the EDA method to process to analyze your data and see where if there is anything wrong with your data or there is any biases or there is any problems in general in there. We'll see the problems I've talked about later during this session. Okay, so I think there's no questions. So you've heard me many times talking about data, and a quick definition before continuing. You might ask what is a data and what you think about when you hear the word data. So one thing for sure, it's almost anything can be turned into data. Be it numbers, graphs, or facts, or quantities. Anything, as long as it exists, you can represent it with data. And as Andrew McAfee said once, the world is one big data problem, which means that anything you can turn into data. And generally, we can find that there is 3 types of data: numerical data, and categorical, or a time series. As for the numerical data, you can split it into 2 types. It can be a discrete or a continuous. For discrete numbers, which are used to represent a non-floating data, like the numbers of attendees, the numbers of test questions on an exam, and so on. Then there is a continuous data, which is used to represent the floating numbers, like how much money a person makes, the price of a potato on a supermarket, and all the numbers that have floating point in them. And as for the categorical type data, you can split them into 2 types. Either they are ordinal, where order matter, like grads, age groups, socioeconomic status, or nominal, where we don't care about the order, like colors, countries, and sex. And you might ask, why should we care about those types? As you know, when you feed the data to your model, it only accepts numbers. So when you have a categorical feature, you gotta encode it into numbers. And sometimes, just by encoding the ordinal category features and while keeping their orders, help improve the results of the model. Then there is, last but not least, there is a time series, the time series data, which can represent the measurements over time, like weather conditions, stock, health monitoring, which can be represented as time series. There are different types of time series and patterns, but I won't get too much into them to details. Maybe in the future session, inshallah, if we have the chance. So, do you have any questions about this? Do you have any questions about what we just saw about data? I think there's no questions. Okay, let's continue. So to analyze the relationship between those types of data we just discussed, we generally use either the correlation for numerical variables or the entropy for categorical ones. The correlation helps us detect the existence of any linear relation between our features. The correlation to zero, the closest to zero the correlation, the more we are sure that there is no linear relationship between those 2 types of numerical variables. But not always we have a linear relation between those 2 variables. Sometimes there exists some nonlinear relations that can be detected with correlation. We can see here that we have zero. We have the correlation of 0 in those different scatter plots, but there is a relation between those 2 features. So we need to visualize our features to make sure that there is no relation between them at all. Thus, it is another crucial task for us to visualize the data in order to make sure that there are no hidden nonlinear relations. You can see that these relations affects your model. If you want to discover more, you can just check the playground of TensorFlow, the TensorFlow playground. I will share it right now. Okay, I think I will share it. You can see how these relations affects our model. If you want to discover them, yeah. Okay, I shared with you the link. Okay, thank you very much. Okay, let's continue. You can also use the correlation between to look at whether there is a linear relationship between two time series or two signals. And where will this correlation help us? Well, having these insights on our data can help you out in choosing the right features for your model, and they can help you detect the multilinearity where the correlation between two variables is greater than 0.8. And you can decide whether to keep those features or engineer new ones from them, or just drop them completely, which leads you to reduce the dimensionality of your model. Thus, it will help you improve your model that uses maybe a loss function that penalizes you on using data with big dimension without improving the model's results. Okay, do you have any questions about correlation? Can you implement some noise cancellation app? Okay, sure, sorry. Inshallah. Do you have any questions about this? I think there is no questions. I will continue. Moving on to the entropy. Yeah, you can use it on categorical data in order to see if your feature is eventually split over the different unique values. And an example of that is the figure you can see right here, where we have a feature that have two unique values. It can be a value. It can be either a plus or a minus. And so we can see that when we have an eventually count of plus and minuses, you can see that the entropy is close to 1. And like when we have more pluses than minuses, you can see that the entropy is close to 0. And will it help us again? It will help us to choose the right features for our model. It helps us understand whether our sample is representative sample or not. And also, it will help us improve the results of evaluation of our model. Okay, so far, I think, do you have any question about entropy? (3ds). Okay. So we've seen the correlation and the entropy. Now let us discuss the different type of charts that will help you in discovering the different relations hidden in your data. For that, we use this popular formula from data visualization. You can decide on which visualization first. You decide on which visualization and visual encoding you to use. We will see it at the end of this session if we got time, of course. Then you look at what type of your data you have. Is it a categorical data? Is it a continuous data? Or is it a time series? And what relationship you are trying to find? Are you trying to find the correlation? Or are you perhaps trying to find the entropy of your distribution, or the distribution of your variable? Or you are just trying to compare the different distribution across multiple categories? And sum up everything, and you will get the type of charts to use. And you can use this thought starter by Andrew Abella. I will share the link right now. Wait a second. Okay. You can use this link. I think will be shut. Okay, it's on share. You can use this thought starter by Andrew Abella to help you out in your choice. But most of the cases we use the most used ones are the distribution and the relationship and comparison is the line chart and the bar chart and the scatter plot and histogram, as well as the multiple small multiples where we mix between a lot of line charts and a lot of bar charts to compare the difference distribution of our data. So before choosing a chart, what should we ask ourselves? We first look at the data type we have. Is my data numerical? Is it a categorical data? Or is it a time series? And how many features I'm going to use, or the dimension you will be working on. Is it a one dimension? Is it 2 dimensions? Or is it more than 3 dimensions? And so, in case you are trying to look at the distribution of one numerical variable, you must most of the time use the simple histogram or a simple line chart, or a histogram over a line chart, of course, which help you in understanding the probability of your distribution and detect the outliers and look at the skewness of your histogram on the law of probability your distribution is following. Or you can use also the box plot or the Weiland plot, or a box plot with a Weiland plot, of course. It will help you out in finding the min, the max, and the mean of your variable, and where you have the biggest concentration of points of your variables, of course, it's the mean. So, okay, let's see an example of this. We will look at this data set, which is the hard disease UCI data set from Kaggle, which it has about 14 features, I think. 14 features. And the goal field is in this data set refers to the presence of a heart disease in a patient or not. You can find it in Kaggle. I will send you the link later in this session. Okay. So when we look at the distribution of the age feature of this data set, we can see that without calculating the p-value or anything, or the measure of skewness, we can say that this variable clearly follows the normal distribution, is normally distributed, and that the skewness is skewed to the left. So, and when we look at the box plot, we can see that there is no outliers in this variable, and that it's quite good looking. It's quite good distributed, and like this feature, which is the Crest BPS, you can see that there is a small skewness to the right, and which the skewness, when we measure the skewness of it, when we calculate this measurements, the skewness measurements, it confirms this assumption, and that there are some outliers that are adding some noise to the distribution, and that this distribution is not normally distributed. And we will look at the box plot of this variable. You can see that there are some black points at the top of this box plot, which represents the outliers in this feature. Okay, and why should we care, or should we get rid of those outliers? And well, when we want to scale our data, for example, those outliers intervene and add so much noise, which makes the scaler not performing well. And there is some loss functions that are quite sensitive to outliers, like the squared error loss. So when dealing with these outliers, you gotta, if you are using, for example, the squared error loss, you gotta get rid of them to improve the model's learning. And when we are trying to compare the distribution across categories, for example, we have two-dimensional data, one categorical and one continuous. We have a comparison of distributions. So when we are trying to compare it, we can use the histogram or a line chart, and to help us see how much separation we have between those two categories. And the more separation, the better the classification we can have later using the model. And the more overlapping we have, the difficult it is to separate those categories using the numerical feature. And so in this case, if we were to use the feature of WCC over categorical to decide whether a person is a female or a male, we can't, because there is so much overlap between those two distributions. And like this feature, you can easily separate those two categories just by a simple conditional model, where for example, the fat is more than 15% or less than 15% just by building an FL's model. And you can also use this histogram to look at the distribution of these two categorical variables when you are trying to compare the distribution over two categories. Okay, moving on to categorical data. To complete the categorical data, you can look at categorical data just by using a simple bar chart. You can see whether your data is eventually split, as we previously seen with the entropy. You can see with this bar chart whether your data is eventually split across categories or not. In this case, we have right here, calculating the entropy of this sample will give us about 0.5-ish percent, 0.5-ish of entropy, which is quite decent. And like this feature, we can clearly see that there are a lot of samples with FBS equals 0. So it isn't at all representative, and using it for our model will not help us well. Okay. So we can use, as I said earlier, we can also use the small multiples, which combines the previous chart we saw, and compare one distribution with another distribution, or just use the bar charts, the small multiples of bar charts to compare them. And in order to look for correlation between numerical variables, there is no better chart than the scatter plot. The scatter plot is just take x and y, two features x and y, and just plot them. And in case you want to represent three numerical variables, you can use the bubble charts, where the third variable will be used to decide the size of the points, or in this case, the size of the bubble. And finally, for the time series, you can use a simple line chart or multiple line charts to look for the hidden parameters and relations between many time series. Okay, I think, can't you... Do you have any questions? Okay. Okay. Okay, the box plots and the violin plots. Wait a second. There is outliers are like noise in a function that should be removed. How do we remove it? You can just clean the data. That's a part of the cleaning of the data. It's not about the explorer. Yeah, it's part of the exploring of the data, but you just try to either remove them at all, or just try to remove the samples that have the outliers. Just remove them. So to help reduce the noise in your data, how I did answer it, a box plot. Okay, not a normal distribution. Okay, box plot with box plot. Okay, this part, I think, was it this part's okay. For the box plot, you can use it to look at the quantile of the first quantile and the third quantile, and look where there is a lot of concentration of your points, or of the distribution that is most concentrated in. So you can use them to look for outliers, and to look where the mean is, and whether there is a normal distribution also in it. No, okay. I think, how do we analyze the dirty data and the image data set? You can just visualize your images. You can just plot them and look at images just by, for example, just using the pyplot image show, or just CVE2 for image show. You can just look at them. You can't, of course, you can't look at every picture of your data set, but that's a task of collecting the data. When you are trying to collect the data from a source like a hospital, you gotta collect it. You gotta collect it right. It's not it's not till you have to explore it, then you will detect the problem, but you gotta collect it from the source to be right. Hope I've answered your questions. If not, I think we've reached the end of our session. These are the references I've used, and if you have any question, you can feel free to drop them right now. If not, I would share with you these links, and I think it's the end. Yeah, thank you very much, everyone. It was good. You can contact me via via my email or via my social media. Feel free to have, if you have any question, feel free to ask. It's not. I don't think so. I don't think your model will, in case you deleted your data, your model. In case of deep learning, the more you have millions of samples, it's not deleting 100 of them is not gonna affect your model. It's not gonna affect your final model, but it will help it improve. Thank you very much, everyone. In case you have no questions, I think this is all. Thank you very much. I will send it to you later. Thank you very much. Have a good day.